Hi guys, welcome to the second video of the series in which I'm trying to explain how a delivery price in an online shop is calculated from technical perspective. Today we will be focusing on a single part of it, which is answering this question: can boxes fit into package? And I will describe all the details in a second. Firstly, you can see that I've already prepared all the notes for you, so it's easier to follow. So let's just go through it to see what the main question actually means. Okay, we can see the input, which is boxes and package. Boxes is an array of vector 2 points, and package is a single vector 2. As you can see, vector 2 is defined as an array of two real numbers, but in this example we will care only about positive real numbers. And obviously the reason why these numbers have to be positive is that we will not even consider negative dimensions when it comes to boxes or packages. Okay, so next we can see that the output is pretty much a boolean, so we're expecting just two answers, true or false. Next we can see what the rules are. So for example, input parameters can consist only of positive numbers, so this is something I told you already. Next we can see that boxes can be translated or rotated by 90 degrees only, obviously negative 90, 180, 270 and so on and so on. And it's important to say that this is a simplification, not something that we do to improve accuracy, but rather the other way. So there might be some scenarios that would fit without that rule, but if we apply it, they would not. And here is the easiest example I could think of. This box cannot fit into a package if it's put horizontally or even vertically. It's even worse. But if we put it diagonally, well, sure it can fit. Okay, back to the rules. Now is the third one, which says that boxes are rigid, cannot be cut into pieces or overlap with each other. And the last one is, in the end, all boxes must be inside of the package if possible. Obviously, sometimes they do not fit. Let's go to some examples that will make it all clear. So the first one. Okay, so here we can see two boxes, which dimensions are 6 by 4 and 3 by 2. And the package we're trying to put them in is 8 by 4. You can also see that the total area of boxes is 30, and it's smaller than 32, which is the area of the package itself. So otherwise, we would already know that they would not fit. Okay, so let's try to answer the question. How would we do that? Obviously, we can just move them around. Let's put it inside of here. Okay, the layer is wrong. I will put it on top. And let's move this guy also to top. But as you can see, it will not fit if we put it like this. But we can use the second rule that says that we can translate and rotate objects by boxes by 90 degrees. So we'll do it right now. We can rotate it and we can put it like pretty much here or here. It doesn't really matter, but we can already see that these boxes do fit into a package. Okay, let's go to the second example real quick. I'll just try to put them inside. So let's start with this one. But as you can probably see, no matter where we put the second box, we will not be able to put the third one. It will always be off by a little bit. So what is interesting that if you look at the areas, total area for boxes is 32 and is the same for the package, it's also 32. So in theory, they could fit, but as we try to visualize this, we can clearly see that it's not the case. I hope that at this point it's easy to say that the answer to the first example would be true, they can fit, and the second is false. And here's the interesting part, because we have to decide on what strategy do you want to pick. And by that I mean what box will be the first one we'll try to put into the package, what will be the second one, and so on, and how will we arrange them. Okay, so let's see this first example. Imagine you put them just like that, pretty much randomly, but at some point you realize that, well, you cannot put that square in, so you would have to rearrange them somewhat, like that, move it to the left, rotate this guy, okay, and then maybe there would be some space for the square, but as you can see, it's still not the case, so it's really tricky. I mean, we have to rearrange the boxes that we have put inside already, well, and that's real tough to do it mathematically. And now on the bottom left, you can see the solution that I've chosen. And the main difference is that we're starting from the bottom left, and we always go to the right and top. So in that example, it would be the first box, second, third, fourth, fifth, and sixth. And now I'll try to explain why it's so important to choose a single flow direction. So let's consider this first example where we have just a single box in. Now we can clearly see that it's best to put boxes in red dots, so there's no gaps, because why would we even want them? Okay, so here's the second example. We have put two products in, and now we can see that there are three good positions we probably would want to put the next box in. But as you can see in the third example, there is some gap left. And if we look at the last example, well, the gap is even bigger, something we probably wouldn't want to have. And at this point, you might think that this script is really inaccurate, because, well, it's easy to fail if you just choose wrong order or a position. But it turns out that it's completely fine because we are not trying just a single scenario. We'll run this recursively for literally any position and order, so we are pretty sure that at some point we'll also try this one, where the gap, well, is pretty much non-existent. Instead, it's on the right side, so we can still put a box in it. And just because of that property, we can tell that the script will work and return false values, like say that boxes will not fit, if they actually do not fit in the real world. I wonder if you know how to prove this property works for any scenario, even if we had 1,000 boxes in a package. Feel free to share ideas in the comments. But for now, thanks for watching. I hope I will see you in the next video, where I'll be showing you how I write the code that does these calculations. Bye!